Dear students, today we shall see about analysis of variance, which is a statistical test to test the difference between the different group means. So what is ANOVA? ANOVA is analysis of variance. It is a statistical method for testing differences between two or more group means, and was developed by Ronald A. Fisher in 1920s and is used in research, agriculture, psychology and biology. What is the main objective of ANOVA? It is to determine whether there are statistically significant differences between two group means. Normally we would have seen in t-test or other test, we will only see the difference between the two, that is the mean, we'll see the difference between the different groups. So here we are comparing between group means. For example, you are comparing the weight of fishes fed with 3 supplemented diet. In the case of t-test, you would have done with 2 supplemented diet, but here more than 2. Okay, so you can check for more than 2 samples. Next, what is the basic concept of ANOVA? ANOVA analyzes variability within and between groups. So this type of variance is very good in research because you will know the difference between two groups or more than two groups. Okay, and the between group variance is to understand the difference due to treatment or factor difference. Suppose you take a group of fishes and you're going to feed it with 3 different diet. What is the change in growth, or what is the reason for the change in growth? Is it because of diet 1, diet 2 or diet 3? So such type of between group variances can be checked. Another thing is, within the group if there are some variance. So suppose you are having 3 different ponds. Okay, so for as replicates you are using, within one replicate, what is the variance do you have? So if there are some errors in your experiment, this also will help us to understand the variance. And finally we calculate the F ratio, that is between group variance divided by within group variance. Now let us see what are the different types of ANOVA. First is one-way ANOVA, where we have one independent variable with 3 or more groups. Okay, so maybe if you're going to take the diet of fish, so diet is only one variable, but you're checking with 3 groups of fishes. In two-way ANOVA, you're going to have 2 independent variables and test the interaction effects. So again you're having 3 group of fishes. One will be on the diet and the other can be boosting the immune system. So you are taking 2 factors, 2 independent variables, and you're going to see the impact of both the immune booster as well as the diet. Then it is two-way ANOVA. MANOVA means it is multiple dependent variables. You can check for different types of variables. Now coming to the assumptions of ANOVA. So according to our ANOVA test, first the data should be normally distributed, and there should be an equal variance among the groups. So that is called as homogeneity of variances. It should be almost equal, then you will get the exact difference between the different groups. And if the variance, if there is no homogeneity, the results will be vague and it will not give you a correct result. Then there should be independence of observations. So these are 3 assumptions of ANOVA. Now let us see what are different steps to be followed in ANOVA. 1. We have to formulate a null and alternative hypothesis. Second, calculate the group means and variance. So as I told you, you have 3 different groups of fishes. So see the means of the 3 different groups and the variance. Compute the sum of squares and the mean squares. And finally, that is the sum of square for between samples and within samples. And also you will also calculate the total sum of squares. And then finally the F ratio you have to find out. Compare F value with the critical F from the F table and interpret the results. So this is an example of 3 groups we have taken. We are going to compare the group means, as I told in the previous slide. We have to apply SS between, SS within, find F, that is MS between by MS within, and interpret the significance. How to interpret your results? If the P value is greater than the table value, you have to reject the hypothesis, which means there is significant difference. If the p-value is less than the table value, you fail to reject the hypothesis and there is no significant difference. And you can also go for Tukey's test to identify which groups will differ. What are the applications of Anova? So Anova has found now lot of applications in education to compare teaching methods, in agriculture to compare crop yield under different fertilizers, medicine to compare treatment effectiveness, both clinical, aquatic or any field, and finally in business to compare the sales under different marketing strategies. So this is a sample Anova table. One is you have the source, between groups, within groups, and total, then sum of squares of between, within and total, then the degree of freedom you have to calculate for the between groups and within groups, and the total and the mean, sum of squares, and F ratio compare with the P value. So based on this we can work out a problem later and then understand the concept of Anova. So what is the advantages and limitations? Advantage, multiple groups can be studied, and the type 1 error, as I told you, within difference will help you to identify the error. So a type 1 error will be reduced. And limitations, it assumes normality and equal variance. So it requires balanced data for accuracy. So to conclude, it is a powerful tool for comparing group means. It helps to identify significant differences influenced by different treatments and often followed by post-hoc tests for deeper insight. So these are the references. Furthermore, you can refer to the web.